let's get into the big topic of open source, something that we actually say at Red Hat.
This is so awesome.
We are an open culture that believes in the importance of
What is that process that a developer, or let's say,
as the Kubernetes ecosystem really boomed?
Good morning, good evening, good afternoon, wherever you are in the world. This is the Ask an OpenShift Expert live stream. Today we have a topic that we've had on before, and now we're bringing it back to kind of get the latest and greatest on it. And more importantly, or not more importantly, but just as importantly, my man, the myth, the legend, Sully, you're back. It's been a while. It's good to see you again.
It has. It's good to be back. I feel like life keeps getting in the way. And it was 2 weeks ago, it was Red Hat 1. Last week, it was, I don't even remember what.
Yeah, Red Hat stuff.
Yeah, I don't. The joys of being a manager, I tend to get pulled away into all kinds of different things on a regular basis. So, but yeah, I'm glad to be back. It feels like riding a bicycle. I think I say that every time. Whenever I'm gone, it's good to be back. It's good to see everybody. It's good to interact with folks. And I have absolutely no worries about your ability to keep everything running, not just keep it afloat, but do an amazing job, Jonny. So thank you for filling in for me in my absence. I appreciate you taking on and just doing everything you can.
I appreciate that. That makes one of us, like at least at least one of us is confident. All right, awesome. Well, so there's not a lot of top of mind topics. We do have the KubeCon EU is coming up. It's at the end of March. It's I think the 23rd to the 26th of March. If you haven't signed up for the OpenShift Commons event, it's a day zero event. Make sure you sign up. Carolyn May is looking for participants. She's looking for just feedback on the event overall. So it's something that we're trying to make better as a company and as a community. So make sure that if you're going to be there, get involved, go say hi, and I'll be there. So it'll be kind of cool. I hope to see you there. I hope to shake hands with you and maybe share a couple stories or whatever.
Get you to sign my badge. I won't be there, but
I'll try. I'll do my best. I'll be kissing babies between 4 and 6. So if I can fit it in. But yeah, so the topic today is the Red Hat Trusted Artifact Signer, also known as Red Hat or RHTAS. And Vita, I'm sorry if I butchered your name. I've already confused myself on how to say it. So all right, cool. So Vita is here to introduce the team. And let's kick it off.
Hey, thank you, Jonny and Sully. Excited to be here. I'm Veda Shankar. You pronounced it correctly. So product manager for the Red Hat's Trusted Artifact Signer, which is an on-premise implementation of the upstream SIG-Store service, which you may be familiar with. It's very popular. So we have an information pack session. And so let's get through the introductions really fast. So over to you, Ehsan.
Yeah. Hi, everyone. My name is Ehsan Mokhlis. So I'm OpenShift consultant from France entity. So I think it's better to share my screen. I did because I want to share something with you guys. So let's start first by sharing my thing.
Hey, Ehsan, real quick,
yeah.
Let's kick off with intros, and then once we'll circle back around and let you kick off your presentation.
Okay.
Does that work?
I'm sorry. Yeah. So it's up to you, Rachel.
Thanks so much. Nice to meet everybody. I'm a software engineer in the RHTAS / DSD UI team. And I've been at Red Hat for over 10 years now.
Awesome.
Over to you, Lance.
Hey, I'm Lance Ball. I'm the engineering manager for RHTAS. I've been a part of Red Hat for 15 years. I guess I'll hand it off to whoever's next. I'm not sure who's next. Joe.
Okay, I'm Joe Stewart. I work on the Conforma team under RHTAS. I'm a software engineer, and I've been with Red Hat for 8 years.
Awesome. There are other people, I'm sure, that are lurking in the background here. So what's going to happen to everybody is as Ehsan is doing his presentation, a lot of us are going to drop off, and then the presentation is going to happen. And then as we start to chime back in, you'll start seeing the videos coming in. So it'll be a little sporadic for a little bit, but just know that we know what we're doing and it's going to be amazing. And if we mess it up, just know that it was all planned and on purpose. So yeah, it's going to be great.
And as always, for the audience, feel free to ask questions anytime that it occurs to you. It doesn't have to be about today's topic. Anything that comes to mind, put it in chat. Jonny and I will do our best to answer those. We'll also ask the team questions as they come up. And they already know, because we chatted about this before. They'll also respond in chat if they're able to and stuff like that. So yeah.
Awesome.
I'll hand over to you.
Yeah, it's for me. Okay, sorry. Let me share my screen. Okay, this one. Okay. Can you see my screen now? Oh, yeah. It comes. Oh, it's not the right one. Sorry. And yeah, it's still. It's very. Okay. So in our agenda today, I think it's really great. So we are going to talk and walk you through Red Hat Trusted Artifact Signer, or shortly TAS, or RHTAS as we call it. So over the next few minutes, we're going to cover 5 important topics. First, we'll start with the basics. What is software supply chain? Because it's really important to clear this concept. What is the meaning of software supply chain, and why we should care about it? Because I think it's really important from my point of view. Then we'll dive into what TAS is and why Red Hat has built it. And after that, I'll show you quickly a demo where we can deploy easily our TAS, and we will see how we use TAS to secure our software supply chain. So what is the meaning of signature, how we sign workloads and artifacts and do verifications and all that stuff. And after, Rachel will show you a TAS dashboards, because for end user, it's really important to see some metrics. They will help them to how can I say that deal with the task from a business point of view. It's really important for the end user, for the clients. And at the end, there is a tool which called Conformer. It's really important also, that helps you to enforce policies. And finally, we'll talk about what's coming next for the task. And by the end of the session, you should understand why signatures matter, sorry, and how it works in the real world and how it fits into OpenShift environments very, very, very well. So this is the most important slide I need you to understand this before anything else makes sense. So let's think of a supply chain like a pizza, the pizza delivery. So you order a pizza online, and it gets made and it goes into a delivery car, I believe in the United States, but here in France, they use more a motorcycle or bicycles to deliver your pizza. And it arrives at your door, and along the way, you trust that. You trust that the restaurant made it correctly. You trust that the driver didn't tamper with it, and you trust it comes from the place you ordered from your pizza. And by the way, I love pizza, and especially the one Napolitan, which is with some fish things. It's really, I like it. So your software supply chain works the same way as your pizza delivery. It starts with your code, the code your team write, but it doesn't stop there. It includes all the open source libraries you use. For npm things, for the pipe for Pythons and nvm jar for Java, and etc. And all, for example, if you are using Node.js, you're pulling in hundreds or thousands of dependencies. Each one is a part of your supply chain. Then comes the build process. So your CI/CD pipeline, whether it's a Jenkins, whether it's a GitHub Actions, whether it's a GitLab CI or OpenShift pipelines, that takes your code and turn it into something that you can deploy at the end. So it could be an artifact, it could be a container image, or it could be a binary there. So anything that you can deploy at the end. That's part of the chain, your chain. Then it goes to your registry, like Quail, like Docker or Artifact, whatever. And finally, it gets deployed into production. In our case, it's OpenShift, or maybe a cloud provider. Yeah.
Can I ask you a question? Which is,
yes.
So a lot of times we think, oh, it's open source, right? Open source is reviewed by the community. There's lots of eyes on it. There's lots of people doing things with it. And we sort of, I think a lot of folks just assume because the code is visible to the world, it's more secure by its very nature.
Absolutely not. Absolutely not, Sully. It's really a wrong idea, and I will show you that in the next slide. It's really a wrong idea. Everyone think that the fact it comes from open source, it's open to everyone, and it's really visible. It doesn't mean it's secure. That's the problem. So at the end, and I will show you this in our slides. At the end, the TAS, the Red Hat Trusted Artifact Signer, it's really the tool that help us to secure our things. Yeah, indeed, there is other tools in the market, also open, but in terms of management, it's not that easy like TAS. It's not manageable like TAS. And all that I will try to show you this in this slide.
Very cool. Yeah, I think it's important to point out that
absolutely.
Yeah, whether you're using open source or closed source software, right? Having that validation and attestation that this is the code that you expect it to be, and this is Red Hat's library or Red Hat's build of whatever, or Red Hat's code, I think is really, really important and something that folks sometimes forget about. And supply chain attacks are becoming more and more common, even and especially with open source libraries, because it's based off of the assumption of security, or the assumption that the people who are clicking merge on those PRs are good actors, if you will, as opposed to people who are, maybe trying to introduce, something bad into the supply chain. So
yeah.
Anyways, I just want to make sure that we set that up front of like, no, just because you're using open source software doesn't mean that this isn't super important.
Absolutely, absolutely. Even I will go more in the far, as we said. Even if you use, let's say, our Red Hat images, for example, they are really secure, they are really scanned and everything. But at the end, as an end user, you will use those images as your base image to build your code on it. So the code that you build, so you need to build it in somehow. So you need to use some framework that you don't own 100%. So how can you make sure that those libraries you bring, or those frameworks you bring, it's 100% secure? You don't know. So the idea here with TAS is really to try to how we use the fancy word non-repudiation, to make sure that this code, this change, this library, it comes from a person that you know. So you can really follow and trace all the, let's say, the sorry, the software supply chain thing, all of it.
Yeah.
So here we stop at this CI/CD pipeline. So and after it goes to your registry or artifactory where you hold your thing. So but here is the critical part. So every single step of all of this is a potential attack vector. Sorry. So someone could inject malicious code at any point. They could replace a library. They could modify your build process. They could tamper with the image in the registry before you deploy it. So when we talk about supply chain security in general, so we're talking about how do I trust every step of this process? How do I know that nothing got tampered with? So this is the question that we try to answer, and this is why is this matter? Okay, so now let's go to some real examples that's really happened. Sorry. So I want to say quickly 5 real attacks that happens in real companies. These are not imaginary thing. This is something really real that happened. This happened in the last few years. There is SolarWind in 2020, which is a company that makes monitoring software. Attackers go into their build system and put malicious code right into their system, their software, and they didn't break anything into their customer network. So the customer themselves installed the malicious code themselves through a normal software update. So here we talk about more than 18,000 organizations were affected. It's something huge. It's bigger. So that's a supply chain attack. Another example of attack. It's Log4j. It's everyone in the market and know what is a Log4j attack. It's a vulnerability in a library called Log4j that millions of applications use, especially the ones who use Java or develop with application with Java. Another example of attack, it's the Cove in 2021. Their CI/CD script got hacked. This script runs inside your CI pipeline and collects code coverage data, and by default they bring everything they can find. They steal secret environment variables, API keys, SSH keys, so anything that was available during the build process. Another example, which is XZ utils also, and the last one that happens just recently in 2025, sorry, which is Shahurut 2.0, the most recent example. This is a half replication worm named after the movie Dune. I like this movie, by the way. So I watched the sequel, the Dune 1 and the Dune 2. So in 48 hours, it compromised over 700 npm packages, something big. It created a 27,000 malicious repository in GitHub. Can you imagine this? 27,000. It's not 1, 2, 3. It's 27,000 malicious repository in GitHub. It exposed 14,000 secrets across 487 organizations. This just in 48 hours. So can you imagine the impact behind? It's really bigger. There are companies who were impacted, like Zapier, like HostHog, and the Postman were really infected directly. So the attack exploits npm install behind. So the malicious code run automatically during the installation. So here, what we can see, this is the same pattern keep repeating himself. The attackers find a way to inject code into something you trust. So here, at the end, they attack your trust, not attacking the system. It's your trust as a user or as a developer or admin or anyone use or involved in the software supply chain. So then that code spreads automatically as people update their dependencies or deploy new versions.
And this isn't necessarily just neglect or I don't want to say laziness, but laziness by those developers either, right? Because it's not like, as a developer, I can't go in and review literally every line of code in every package that I'm including in my, whatever application I'm creating and deploying. Because there can be, like you said, there can be hundreds or thousands of different dependencies and packages included in there. So we have to have some sort of trust there. So it's not like somebody woke up in the morning and it was like, you know what, I don't feel like doing this review today. I'm just going to npm update and YOLO. It's very much more seditious than that.
Yeah, absolutely. So here, I'm not going to be paranoid, but this is the reality of things. So there are some concepts that we need to respect. Even it's heavy as a developer to do all of that, but we need to respect. So the process, we made process to minimize those kind of risks and attacks. So we need to respect that. So here, the fundamental question in supply chain: how do I know what I deployed is exactly what I intended to deploy? Here, let me break this down into 4 specific questions. So the first one is this artifact what's the author intended? Sorry. So when you deploy an application, are you getting the exact version that was built by your team or another version? Or could someone have swapped it out? Could there be a newer version in the registry that you don't know about? The second question is, has it been tampered with? From the moment your CI pipeline produce that image until the moment it runs in production, is it really the same? Is it changed in somehow? Could someone have modified? Could someone with access to the registry have changed the image layer? That's possible, but how can I make sure it's not tampered with? Sorry. Could there be a man in the middle attack happening when you pull the image? A third question, who built it and when? You need to know not just what something was deployed, but who built it. Is it you, Sully? Is it you, Jonny, or anyone else? Is maybe another Michael who's not allowed to run that pipeline, for example? And also, so you need to, at any moment, to have access to a full audit trail. So you need to be able to try to trace and track back through the entire build process. A fourth one, sorry, question. Can I prove this to auditors? How can I prove it? And especially for restricted environments, a sensitive environment like finance, like healthcare, like governments, the moment that you need documentation or to do auditing, whatever. So you need to show auditors that you have controls in place. So you need a paper trail that prove nothing was tampered with. So this kind of questions that we need to answer. But at the end, the answer to all of that is a cryptographic signing. So, but here there's a problem with the cryptographic signing. Has historically been really hard to manage. If you ever use the PGP or GPG, so you know what I'm talking about. So it's really hard to manage. So you have to generate keys, you have to manage them, you have to keep them secret, you have to revoke them when people leave. The user experience is really terrible to manage these kind of things. And most developers avoid it because it's really heavy to manage all of that. So that's where RHTAS comes in. RHTAS makes cryptographic signing really, really easy. It handles the hard part automatically. There's no need to do things from your side. You have a RHTAS who will do the job. So you don't have to worry about revocation or it just works. So this is really a problem that we are trying to solve here.
And that's the part that I really love about it, right? Is it adds all of this, like you said, trust, all this confidence, but it's not a heavyweight overhead process for either the developer, the individual, or the organization. It's really meant to be as seamless and transparent as possible while providing all of those benefits. Yeah.
So here, in this slide, so before we talk about the solution, let me explain why signing has been so hard. So I want to try to and show the difference, what's happened before RHTAS and what we gain after RHTAS. So a cryptographic sign-in is really powerful. It verifies that content hasn't been tampered with. It provides something called non-repudiation. It's a fancy word and that everyone uses in security. So that means that the person who signed something can't later claim they didn't sign it. So if you solely, for example, you run a pipeline and behind you use a task to sign that thing, at the end you cannot say, no, I'm not the one who run it. I'm not the one who triggered that things. So it's really difficult. So so the signature proves they did. So if you bind the signing key to a real person identity, so you know exactly who signed what, and you can verify who signed it when it was signed and what was signed. So the signature is based on the hash of the content. So just a small change of a byte and the signature becomes invalid, which is this is the beautiful thing of mathematics. It's really impossible to fake a signature without the private key. But here we talk about the private key, and this is the big but. Managing the private key is really and incredibly difficult. Think about it. So you have a private key. It needs to be secret, which means only one person or system should have it, not shared with everyone. It should be available, which means that you need it whenever you want to sign something. It should be backed up, so if you don't lose it, so you have something to get it back. and protected from deletion. So, but here still need to be replaceable if it's compromised. And the last thing, which is accessible from everywhere, wherever. Sorry, you're signing your CI pipeline, your local machine, whatever system you use. So these requirements conflict with each other. So how do you keep something secret and available at the same time? How do you back it up without creating copies that someone could steal? It's really difficult. And this is the first thing. The second thing, which is security standards, are really complicated. So everyone deals with standards and security standards. It's really complicated to implement all of them and respect all of them. So because if you increase the security, from the other hand, management thing, you will make it just difficult. The user experience is really terrible in this kind of situation, because for the classic BGP, so I know developers who have been using BGP maybe for 20 years or more, but still find it confusing for them. So you have to manage keyring, you have to understand trust models, you have to manually verify signature, and it's not something you can do casually. It's really difficult. Another problem, which is revocation in a mass. So let's say a developer leaves your company. So you need to revoke their signing key. So let's suppose that you have 10 developers or maybe 20 or more. So how can you manage that? It's really difficult. It's not that easy. And another thing, which is it's not designed for automation by design. So the most signing tools were designed for individuals, not for let's say an enterprise scale that will be used and automated for everyone. So you end up at the end with a situation where the thing that would help you secure your security the most, which is automatic cryptographic signing, it's the hardest thing to implement and maintain. So here, what TAS solve as a problem? So TAS really gets interesting. Instead of managing private key, TAS use something called keyless signing. And here's how it works from a high-level point of view. So instead of a long-lived private key, you use your identity. So when your CI pipeline runs, the developer is already authenticated to the system, and they log into their for example, a GitHub or GitLab accounts, or whatever identity provider they can use. For example, you can use also Keycloak, which is our identity provider solution provided by Red Hat also. So that's your OIDC identity. We use that to prove that this code was built by a known and authenticated user. The signing happens through a certificate authority, a trusted third party. In our case, we use something called Sigstore, because the tabs is based on Sigstore upstream project. So it's what issues a short-lived certificate. So this certificate is only valid for a couple of minutes. So and we use that certificate to sign the artifact. Then we throw away the certificate after. So everything gets recorded in a transparency log, which is really important. So from an audit perspective, everything it's traceable. So you can just go to the transparency log and you can see everything there. The git commit, for example, are also signed. You as a developer, the moment that you change a code, the moment that you commit your code, you can really sign it with TAS, which is something great, which is really wonderful. Because sometimes in a real case scenarios or environment, you have a project, but just a few people who's allowed to do the changes of the code, not everyone. So with git commit, with signing git commit, you know exactly who will change the code or who will push that change into the code. All the signature provenance. So when we sign an image, we're providing this image was built from a git commit by this person at this time and in this CI pipeline. So you have a complete chain from code to production. This creates also non-repudiation, which is the fancy word that we keep saying and using, because the signature is bound to a real person identity. So at the end, they can't claim they didn't build it. It's cryptographically bound to that person. And the key insight is this, that we use your existing identity system instead of managing separate cryptographic keys, the way with PGP and GPG. So you already have your OADC, you already have your identity provider as an enterprise. So we just integrate that with what you already have. So this solves all the problems from the previous slide that we keep talking about. So there's no key management. We use identity instead. So there's no short life certificate that can't be stolen because they expire quickly. Automatic revocation at any time. So the certificate expires, so we revoke everything. It's automatic. It works great with automation. So there's no secret to store at all. And at the end, which is the most important part in the security thing, it's the transparent audit trail. So everything is logged there, everything. Yeah, I'm speaking to that much. I'm sorry.
No, one, it's really cool. Like everybody knows, I'm not a developer. So to me, a lot of this is really, really interesting, and like I parallel it to the world with admins, right? Where we have a lot of things with, like, a simple example is sudo logging, right? Every time I do something with sudo, it gets logged, and RHEL 9 or 10 introduced, right, the replay feature and stuff like that, where we're able to go back and see all the things that are happening here. That being said, I'm also familiar enough with all this stuff to know this is not easy, right? Like you said, you reiterated multiple times, and I 100% agree. Like, all of these things separately are hard, and so it's phenomenal. And I'm really happy to see, you know, not just Red Hat, but I know that there's a whole, you know, industry popping up around these things. Like the simplification of this process and just streamlining it so that we can get all of those features and capabilities without burdening our you know, our developers, making their overhead and their processes that much harder. Separately, I'm curious as to, at some point, if they're going to be like there was no AI involved in this type of similar tag, where there's like attestation that this was all human written code or something like that. But that's neither here nor there conversation.
Yeah. So we finished with what Red Hat Trusted Artifact Signer capable to do and solve as a problems. And the here in this slide, so now I think we really understand how signing works. But let's talk about real world, let's say, scenario. So the task has several key use cases for it. Sorry for my English. It's my third language. It's not the first one. Sorry. TAS, as I said, has several key use cases. Sorry, and they all built on this foundation of signing and verifying. So the first one is signature verification in your pipeline. So you can enable signature verification at a different point in your container registry before the image is even stored, in your container runtime before the image is built or pulled, sorry, and in your admission controller in OpenShift, it's before a pod scheduled. And the great part is that task works with any pipeline. So either GitHub Action, GitLab CI, OpenShift pipeline, or other pipeline system. So whether it's really compatible with a lot of pipeline systems. A task really integrated with all of them, so you don't have to change your pipeline. So you can just integrate tasks with your pipeline, and that's it. The second is verifying third-party code. So you can verify that open source libraries and dependencies actually comes from who you think they came from. We use tools like Git sign to sign Git commit, and Recore, the transparency log, make the signature verifiable. Sorry. A third, which is the compliance, which is really, really important thing here. So if you are in the healthcare, finance, government, or other regulated industries, so you need to prove to auditors that you have a control in place. So TAS gives you that proof. You can show auditors, here is a cryptographic signature proving this code comes from an approved source. Here is the build process it when it's through. Here's the who approve it, and that's really a powerful documentation. And I will give you an example because I was really involved in the first implementation of TAS in the EMEA region with one of the biggest telco company. It's a Red Hat client. They say, hey, Red Hat, we have some kind of compliances and regulations, and we need to secure our software supply chain. And the moment that they reach us, so we propose TAS, and TAS fits perfectly their need, and especially that their environment's really restricted. It's really complicated. The way how it works, it's not that easy to manage. But here I want to mention something, and it's really, really important for me to do that. I would really love to thank the engineering team. Lance is the head of the team, and also Veda, because from the day zero, everyone was involved from Red Hat, the business unit, the engineer, everyone was involved with the client, so that we can provide a product that respond to their needs. And at the end, the client was really, really happy with what we delivered to them. And at the end, we delivered one of our success story of TAS in the EMEA region, which is something, it's not that easy, and especially if we know the French mindset. And at the end, they give us a 10 on 10 as a CSAT. So from a French culture, it's really, really, really difficult to get 10 on 10. It's not that easy at all, because for them, if you do something perfect, the maximum that they can give you, it's just 8 on 10 or 9. But to give you a perfect score, it's not that easy. So it's really important to mention that. Yeah. So and the other, also another way, another real use case where we can use Red Hat, which is how can we secure the supply chain of our AI and machine learning development thing. So TAS, it's not for traditional, let's say, software supply chain. So we can use it also for anything related to the AI and ML things. So we can use it also to secure all that stuff. So I will not go into details in this party, because we have other guys with us who have more knowledge about it. They will speak and try to give and provide more details about that.
I'll quickly point out, I like seeing this bullet here because it wasn't something like, until I saw that bullet, it wasn't something that I'd even really thought about. But when you start to think about it, we, as I think as the world, right, as we implement and see more and more LLMs out there that are answering questions, and we're starting to see LLMs that are actually taking actions inside of applications and making things happen and stuff like that. Like making sure that that data, the things that it's sourcing, are the things that we want it to, right? It's not going out and pulling random websites and executing commands against whatever my application is, or if I'm using it for managing my infrastructure. I think of Ansible Lightspeed or something like that, where it's generating playbooks. I want it to make sure that it is the sources that I want it to be. So I hadn't even thought about that or considered that, and that's really cool to me. I'm really happy to see that.
Yeah, absolutely.
One thing, sorry to jump in, is so excited about this model transparency library, and the fact that the same tool can also be now applied to AI. How often otherwise we'll say, oh, you have to use this for a container image, and some. but and there's a complete consensus among all the who's who, the Microsofts and the NVIDIAs. Everybody is using now Sigstore for signing the model, and we have done contribution upstream with to the library, the Python library, as well as to the model validation operator, which kind of now admits a model only when it's signed into an OpenShift namespace. So if you guys let us, we'll have a session just on that, one of these days. So thank you.
Okay, perfect. So I think now it's time to switch to a quick demo. So I already tried to, to prepare all the and provision all the infra related to this demo, and try to show you in live how we use in deploy tasks, and how we use it inside the pipeline. So I will switch the window. Just give me 1 second here. Sorry. Yeah. So I think. Okay. Okay. 1 second. Can you see my screen? Oh, yeah. Yeah, that's perfect. Sorry. So so let's start. So to deploy tasks, you have multiple ways to do that. Either you can use a manifest directly, or you can use an operator hub, or using GitHub's approach. So the easiest part is to go to the operator hub and click and search for tasks or RHTAS. It will show you the operator, and just click on that, and that's it. It will deploy the operator for you. For my end, I use a GitOps approach. So here, all the components managed by Argo CD, and I have the code for it. So I use here Gitia as my source of truth. Sorry, where you can find all my infra configurations. And what is matter for us in this moment is the operators. I will not go in details how to do that. So there is a lot of documentation from the official documentation of Red Hat. You can just go there. You will find how to deploy tasks with, and what is the configuration to deploy RHTAS with Argo CD. I will go to RHTAS, let's say instance. So here we have two concepts. We have the operator, and we have the instance. And the CRD who's managing and deploying, let's say the task, it's called secure sign. You can just go to the secure sign. This is an example of a configuration. What is the most important thing, just for now? I will not go into detail, because if I go in details, maybe we need more than 1 hour, maybe hours to cover all the possibilities and configurations with tasks. But here, the most important thing is the OEDC issuer. In our case, we use the GitLab. So GitLab, our OEDC provider. We can go to the GitLab. So I deploy a GitLab inside OpenShift, and you can go to the application, create an application from a GitLab perspective, and bring those informations and put them here. So I create a client ID, which I call Sigstore. The issuer is the link of my GitLab with the issuer URL, and the type here I use a GitLab pipeline. So there is different types of OEDC issuers. So we have a pipeline, we have an email, and we have a Kubernetes. So there's 3 types. What concerns us in this demo is the pipeline type, which means that it's the pipeline that I will run inside the GitLab is the one who is responsible to sign the either the artifacts, the container image, or do attestation with other things. It's the pipeline. It's not me as Isan or Sully or Jonny or other ones, because the other type, which is email, which means that you have a pop-up. You as a person, you need to go and do authentication and sign it there. So this is the configuration. It's already synced here to make sure that my application or the secure sign it's really deployed correctly. There is a namespace which is called a trusted artifact signer. I can just go there and check the workloads if it's the workloads already deployed there. So here the most important component of secure sign or RHTAS, sorry. So you have a full shoe server. You have the recore as transparency log. You have this is the database Markle tree. You have a TSA in top. So this is the most important component of our task. When everything it's deployed, you can just go to your application. So this is my application. So I create a GitLab configuration. So this is the way how I manage it. So I call all the stages. Like the moment that you push your code, you need to do a linter format, run your test. Of course, because you build, you need to create an SBOM, which is software bill of material, which means a list of all your the dependencies that you use to build your application. So at the end, with Conforma at the end or other control policy, whenever you have a problem, you can just say, hey, can you list all the applications or the build that use this dependency and this version of dependency? So you have something there. You can easily find what components are really impacted with that specific, let's say, library or dependency, whatever component is really infected. So in the pipeline, the process, of course, I run a vulnerability scan. So I need to check that my code is correct. The need to scan also the container image also if it's really secured. And here I run the process, which is a signature. So I need to sign that, and to sign it, I can just go to the job here. Oh, it take a little bit of time. It's spinning. Come on. I'm sorry, guys. Yeah. So this is it really happens with demonstration. So it's not stable all the time.
Johnny has many horror stories.
Oh yeah, this is my bread and butter right here.
Guys, it's keep running. All right. Anyway, that's embarrassing, guys. I'm really sorry for it.
No reason to be embarrassed. I like to point out it just reassures everybody that we're using like actual live demos.
Yeah.
Because the real world is never as pretty as we show in the videos that we publish.
Okay, it's really, come on. Okay. I will try to. Anyways, okay, let me do something. Yeah. Anyway, so the idea here it's sign is to run the cosign command. There is a command where I can run it inside the pipeline, and I say, hey, cosign, which means sign this artifact or this container image, and this is the issuer I'm using. This is the configuration I'm using. And this is the task to use. To need to consume to do the signing. So we will do the signing and push everything and create the signature and create the certificate, and he will push all that into a record. And after, because it's signed from a point of view, so I need to make sure that it's really signed. So I run again another stage where it's verified, which means that the cosign will call the RHTAS and say, hey, this guy he's already signed an artifact or a container image. Can you please make sure or verify it's really signed? So the moment that he says, okay, it's verified, it's signed and verified, for me, I can just deploy it into my environment, which is the development environment. Here, I want to mention something which is really, really important to understand. Tasks give us the ability either to automate the whole process or maybe to use a hybrid process, which means that a part is automated, another one is a manual. With our clients in the EMEA region, the moment I work with them to implement all of this, from a regulation point of view, they need to run a manual verification. So there is a persona, a physical person, that need to run the verification to make sure that the image or the artifact, it's really signed by a specific pipeline, because their regulation, they say you need to do that. And especially if it's a complicated environment. So here we talk about a 5G. For the 5G point of view and regulation point of view and security restriction and all that stuff, so they need to enforce, let's say, a human verification. So TAS give us this ability. Either we automate the whole process, or we can use a hybrid process, which means a part already automatic, and the other part it's a manual. And after we deploy we deploy our image into the let's say developer environment, the developer, they can just do a merge request into the main, and the moment that the pipeline for main it's triggered for staging, for example, so he will do what? He will do a promotion based on promotion strategies. There is no need to rebuild your application. So he will just grab that image that you already built, but before he needs to verify again if it's really signed, and he will run another verification. It makes sure that the image or the artifact is built from a specific branch, which is really important. So here you force everyone to respect the process. I will not tolerate a deployment of any code that comes from any branch. Only the branch that respects let's say the branching strategy from an enterprise point of view. It's really important here. He will do the same for the staging, and for the production, I can force the multi-signature verification. I will say, hey, Mr. Pipeline or whatever, Mr. person that you trigger the deployment. So I need to verify the code from which branch you built. Is it already signed and verified in all environments, which means development, staging, pre-prod, whatever. I work with clients, they use more than 6 application environments. They use dev, staging, staging 1, staging 2, the pre-prod and prod. It's really a mess for them. But I can force the multi-signature verification. I can force also if it's really contained an ISBOM. I can force also the fact if it's already scanned. If it's scanned, it's okay. I can pass it. I can deploy it. If it's not, I will not do that. Even I can force and say, hey, I will not deploy any any image that's not approved. I need the attestation of the approval. Is it really there? If it's not there, I will not deploy my application. This is the real scenario that I'm sharing with you guys. This is a real world where big companies, when they have a really security restrictions and regulations, they do this kind of things. Just to show you how much task it's really flexible, how much task that can cover, and I can tell that cover almost 100% of all the compliances and regulation standards that we have in our days. Here we talk from Europe point of view or EMEA region point of view. We talk about NIS2. We talk about ANSSI, which is the French National Agency for Security and IT and all that stuff. So it's really 100% compliant with all of these things. Let's go back again. I'm really sorry. Let's see if I still, yeah. I'm really sorry, guys, but
yeah, don't be sorry. It happens.
Yeah. So it's really TAS really covers a lot of things. Yeah. Oh, yeah. It stopped. Okay. So let's stick to the sign here. So this is the configuration. So the signature part, you can just run the signature thing. you need to mention, of course, and use the full seal link, recall, VDC issuer, identity token. This is just to another thing. And the output, which is really important, it's SIG and CRT. And so these two outputs, from an audit perspective, we need to push them and archive them. I know for some cases, from some regulation thing, they request at least seven years of archiving this kind of things. So at any moment in 7 years, they came to you and say, hey, Mr. Klein, whatever your name, I need all the signature that you did, all the track for the last 7 years. So you need to bring all of that. So it's really important to take this into consideration the moment that you install or you use a task in an enterprise environment. So this is all the part related to sorry, to the signing. The verification here is just to verify who signed it, who is the issuer, OADC issuer, who signed that thing. This is the multi-signature verification. Here in the real case, you use the image and you deploy it into multiple environments. So you need to make sure that you verify all the process, not only the stage where you build or you want to deploy your things. So you need to verify all the other environments. So this is a stage or where you can really verify all and do all multi-signature verification, which is really, really important in a real case scenarios. Yeah, so let's try to see if we are able to trigger anything. Yeah. So this is a standard pipeline. So I know that I have an issue here. I would not be able to trigger any build. Okay, so this is the process. So we start with the lane code, test code. We build our application, the back end and the front end. We generate an SBOM, and here we goes to vulnerability scan and signature and deploy the thing. And also we can do an online verification to make sure that everything it's good. So I think this is all I can share with you guys. I'm sorry that the demo it's not that it's not working as it should be. Maybe the next time. And I will switch to you, Vida or Rachel.
Yeah, I think
if you have questions for me.
No, thank you, Isan. This was great. Yeah, and in fact, I have a GitLab pipeline, but I think instead of going back and forth, and we're also on the top of the hour, so I'd like Rachel to kind of share with her the dashboard, and also she's come up with a great learning site, which I think a lot of folks who are not familiar, right? So even before they get to playing with an actual CI/CD pipeline, they would probably benefit from the website she has created and how they can become familiar with just signing anything, right? Even a text file. So over to you, Rachel.
Awesome. Thank you so much. Can you see my screen? And can you hear me?
We can hear you. Can't see your screen yet.
There we go. I got it.
Okay, awesome. Thank you. So up to now, we've talked a lot about why trusted artifacts matter and how TAS sort of fits into the ecosystem. But what I want to show you today is the TAS console, where sort of that trust becomes more like human verifiable, human readable, and actionable. And in a way, it makes TAS more accessible as well. I've already set up an OpenShift cluster with TAS ahead of time. Everything was deployed, a Keycloak instance as well, and I configured my local environment for signing. The console, because it's in tech preview, basically it has some custom deployment instructions. So you would need to follow that in the project README. Okay. So what we're looking at here is sort of when you think about what the console is supposed to represent, it's really supposed to give like teams a clear, trustworthy view of their signed artifacts, of certificates and transparency log data. So what they want to see immediately is they want to like quickly just understand, okay, is the trust root healthy? Am I having any certificates that are expiring soon? Is there any critical things I need to look at? So, obviously here we don't have any certificates expiring. Everything looks like all green and boring. But yeah, the idea here is that you have an ecosystem that's backed by continuously monitored trust roots that you can easily see here.
Boring is good. That means everything is working the way it should.
Yeah, exactly. It's almost like the best demos are the boring ones because they show a healthy and a happy system. But yeah, so the console is intentionally artifact centric. Everything starts with an artifact reference. So an image, a digest, a tag, really the way that OpenShift users already think about workloads. So here I'm going to search for a container image. Actually, this one happens to be a personal project of mine, which we'll look at in a moment. It's called Sigstore Playground. Oh, all right, the demo gods don't hate me today. Okay, so so immediately here you can see its identity. You can see things like the digest, registry size, metadata, basic stuff that you might be able to see in Quay or in Key. But with the key difference being that now we're looking at it, before admission. This is the same artifact that maybe OpenShift would eventually run, but you're kind of having like this view ahead. But yeah, once we have an artifact, we can see what claims exist about it, and that's essentially what this view is supposed to be. You have your signatures, your attestations at a glance. You have you're basically surfacing the same cryptographic facts that you'll later basically your automation will rely on later on. But essentially you can see here that you have like an immutable proof with the recore entry at the bottom. You can actually, if you want to explore it further, you can open a link into the recore search. And you essentially have your certificates chain and the leaf certificate, and the same goes for every attestation as well. Where an attestation might be something like an SBOM, for example. But yeah, so essentially, and one other thing I wanted to cover was the time coherence. So the time coherence compares the integrated time to the certificate validity window. So this is something that is not essentially part of a signature or attestation, which is why we have it as kind of the artifact metadata. So one other thing I wanted to show quickly was the record search UI. If you are already familiar with Sigstore, you may have already heard about it or used it, but it's a web interface that allows you to look through the transparency log that is basically the foundation of Sigstore's trust model. And so you can just search, inspect, verify artifacts, certificates, and so on. So I'm going to actually use a commit SHA that this is from when I first set up code signing with Git sign for this playground project. So basically same old as the record search UI. You've got your public key certificate, essential things if you want to kind of really dig deep into the logs. Basically, this artifact that we're inspecting here is, as I said, is a personal project of mine that I made for fun, and it was made just to make it easy and approachable to learn about the Sigstore ecosystem. The idea is to make because sometimes I think like code signing and the Sigstore ecosystem can feel it's quite developer centric and can feel a bit sort of foreign, and there's some sort of expectation of that you have some like basic understanding of cryptography. So it's kind of
funny you say that, Rachel, because literally I was thinking to myself of like, I've been doing this for a while. I've been in the industry for 20 plus years, and like every time we have a security topic on the stream or even just in day-to-day life, I learn new things constantly. And it's like I was just messaging Jonny of like, what's Recore? Like I need to go and like figure out and like research what Recore is, because it's not something I personally am familiar with and where it fits in. And so like something like this, like like exactly like you said, it feels a little foreign. There's things that I need to learn, things that I need to catch up on here. So
Definitely, and yeah, I mean, it's not an indication of anybody's like sort of technical knowledge. It's also more just like familiarity, and sometimes people can shy away from something, whether it be a certain practice or a certain product or anything, because they're intimidated by the technology that's that surrounds it or that it's based on. So yeah, the idea here was really that, just to make it sort of more friendly, interactive. You can kind of click through the 6-door signing journey, and you can see the artifacts that are generated along the way. You can give feedback here to us, tell us, if there's any way that you would like to see it improved, and you can also explore the the individual components of the ecosystem and quiz yourself. What's the main advantage of 6-doors keyless signing? No need to manage long-lived signing keys. Actually, fun fact, if you clone this project locally, you can see that it practices what it teaches, because it uses 6-door for its own security, like complete with an SBOM generated as well. And yeah, this was basically signed using Git sign and GitHub's new attestation API, which, if you're not familiar with it, is basically like cosign as a service. So yeah, and there's also I believe this must be the outdated version. Let me refresh. Okay, yeah, I was playing around with it today. So there's a new advanced section as well that goes into, it touches on topics like attestations, provenance, SALSA build level, SALSA provenance, and policy enforcement, which is a really important section. Where this is where I wanted to kind of segue into us discussing policy enforcement with Conforma. But yeah, I believe, I'm not sure if we will still be covering that today.
Yeah, I will leave it to Jonny and Sully, but I think we have, but great website, and thank you, Rachel, for that, the segue to Salsa. And if Jonny and Sully are okay, we'll come back on another day, like early March, and we'll do a complete deep dive on Conforma, because that's such a wonderful companion project to the 6-door that we have, and we have productized it, so it's part of the Red Hat Trusted Artifact Signer. And Joe, who is with us here on the panel, he has actually created something super cool, because you got to have AI, right? So you can actually conversationally create a policy which will validate all that stuff that Isan talked about, validating the signature, including that SBOM as attestation when you build an artifact. It is normally written in a language, OPA, open policy, so in Rego, but Joe just came up with this tool to kind of conversationally create the whole thing, so yeah, we'd love to showcase that. Joe, you want to add anything to that?
No, I just think if we're going early March, that'll give us some time to kind of add a little more to the demo, and I think it's a good idea. So.
I have many questions about that. That's exciting to me, because they're using MCP, and
Yeah. So right now it's just we just set it up using Claude Code and Skill, but I think we could add some more to it with some more time. So.
Yeah, no, I'm definitely looking forward to that. I think that'll be really cool, and especially it'll pair well with some of the stuff that's going on. I think even as is with the Claude Skill, I suspect it'll pair well with like the OpenShift MCP server, which I believe is in tech preview now. It's either tech preview or dev preview, I don't remember. And so like that whole inner loop, outer loop developer, experience and linking in with that. Anyways, I'm sidetracking now. It's exciting to me.
Yeah.
I think Lance is also here. Maybe all this wonderful engineering work, he's been the one, leading the team. So I'd love for him to kind of just chime in a few words, because I think we're doing some other exciting stuff other than, of course, AI, Conforma. Lance, do you want to add anything?
Yeah. First, I just want to say thanks, everyone, for your time today and showing off this great stuff. It's really awesome to see it. And it's great to see the stuff that's coming down the road, like this stuff with AI policy and Conforma. And AI is a big area, obviously, where folks are are interested. And things get a little weird when you're dealing with assigning AI models. It's a little different than signing, say, for example, a CLI binary, because an AI model could be massive. So we've been working on that as a team, and also in the upstream with SigStore and the Model Transparency Project. And we've got some great stuff coming out this year around model transparency, validating models as they go into production and in real time. And then another big area that we're working on over the course of this year is post-quantum. Post-quantum is going to be something that sneaks up and bites us probably really soon, sooner than we expect. And you want to make sure that all the stuff you're signing is quantum resistant. We're not quite there yet. We got some proof of concept stuff working and should have that available hopefully by the summer. So we'd love to come back and show that once it's available.
It's funny you brought that up, because as Isun was going through and showing, certificates and the signing and everything else, that popped up in my head of like, is this a concern from a post-quantum world? And I know Red Hat in some ways is leading the charge in that. I think RHEL 10 has a bunch of post-quantum safe cryptography libraries and stuff like that. But it's really good to hear that we are thinking about that.
We are. I mean, all of this is actually, one. Of course, we want to sell products, but we want our own products to be secure. So just to be really clear, like all of this signing stuff that people have seen today, that's actually what we do internally when we're shipping software at Red Hat, and we have, a goal to be shipping quantum safe signed binaries and images before the end of the year.
Yeah, I don't know, Lance, if you want to say a couple of words about like what does the quantum safe mean and kind of what's the impact of that. I'm happy to take an initial swag at that for anybody who isn't familiar with it.
Right. Well, I'm not a cryptographer myself. I'm just a lowly engineering manager, but I understand the concepts. So the idea is quantum computers. Once quantum computers are fairly widely available to state actors and large corporations, it'll be pretty any existing cryptography. So that means that nothing will be safe, right? Quantum resistant algorithms that sort of make it so that quantum computers can't necessarily break the encryption. There is some threat already today with the fact that bad actors could be taking data that is signed with classical cryptography and storing it until the point at which quantum computers are available. So that's kind of where we start, is on that stuff with data at rest, and then and then lots of big stuff will happen. I don't know. It's
it's an interesting thing, right? Because you're right. There's two sides of it. There's one which is, hey, the last 50 plus years of cryptography is going to be susceptible once quantum, reaches the point of being able to break those codes, RSA and everything else.
Yeah.
So any data that's stored in an encrypted state and currently inaccessible might be accessible in the future. And then the other side of it is like, yes, if you're not using a quantum safe cryptography, whenever this, hypothetical future happens, I look at it as we don't know when that will happen, but we suspect it will happen, much like a lot of people speculate about AI gaining consciousness and all that other stuff. Like, it's theoretically possible. We think it could happen, but we don't know when it'll happen. It could be tomorrow. It could be in 20 years. But anyways, having that cryptography be safe so that when you're banking, when you're one of the examples I heard somebody give was like the communications between like airplanes and the ground that are encrypted, of like, hey, this could be broken and suddenly like the airplanes are receiving bad data that is, like not valid for their altitude or other information that's inside of there and could lead to, just crazy things happening. So it's a really interesting field, and I'm super happy that there are some ridiculously smart people here at Red Hat who are working on it. I've had the privilege of meeting a couple of those folks, and anyways, I'm super happy that we're thinking about it sort of in all aspects, ranging from our own build pipelines and attestation, all the way up through ensuring our customers have access to the tools in order to protect their data and everything that's happening.
Yeah, I kind of look at it as, well, first of all, we don't know when it's going to happen, but we do expect it to happen before 2030. Those are the guidelines and the requirements that are put forward by, our federal government. I kind of look at it a little bit like the Y2K problem. I'd love it if we get to the point where quantum computers are widely available and it's a non-issue, right? Kind of like Y2K was, right? Like it was a big issue, but we solved the problem before it happened. So that's our goal, is to solve the problem before it happened.
Yeah. Those of us who've been around for a minute, like Y2K happened and it felt like it wasn't a big issue, but that's because everybody took it seriously. And there was so much work that happened behind the scenes that made it into not of an issue. And this is, to your point, definitely another one of those where if we don't do anything, it's going to be an issue, but hopefully we do all the right things and it's just another day. So there's a question here from Abdul about what we think about, or what any of us think about Claudebot. I will admit, I am not familiar with that. So I don't know if, Lance or Vida or any of the other folks who are on have any thoughts there.
So do we talk about the latest trend that everyone keep talking about, which is the open bolt? Is it the same thing or something else? And I would really love to understand more. What do you think? What we think about Cloud Bolt? From which level? From which perspective? Is it to integrate with OpenShift or to use it in our Red Hat ecosystem? So what is the level? Maybe Abdul asked about, so that we can provide answers. Because I believe that there is an open claw, if I still remember. There's a trend now, which is, I believe, if we talk about the same thing, so that everyone's keep talking about an AI assistant, so that you can build it locally. They will do a lot of things for in your behalf. Generally speaking, it's an AI agent. So if you use any, let's say, OpenShift or Red Hat component or product, so I think you can connect it with your component and do whatever you want, like troubleshooting OpenShift, do deployment, or other things. But again, do we talk about the same thing, which is open claw, or we talk about something else? I don't know.
Yeah. So Abdul, and that was Isan that was talking there. Abdul, if you have any clarification on that, feel free to add that in the chat. If for whatever reason the stream ends before you're able to clarify, or if you want to reach out and we can follow up offline, both Johnny and I have our email addresses listed here. So Abdul, in addition to you, anybody who's watching us, whether live or not, you can reach out to us anytime to ask questions, to get clarification, to suggest stream topics. Johnny and I are always open to new topics and ideas for things to talk about. So feel free to reach out to us. By far the easiest way is email. You can reach me at Sully, SULLY @redhat.com, or Jonny, JONNY @redhat.com. And we're happy to help with all those things, and that includes bringing, if Vida or Isan or Lance or whoever, we need to bring them into the conversation to help answer those. We're happy to do that, as well as pulling in other folks from across Red Hat. Johnny's famous now, so he just has to ask the question, and folks volunteer. They jump up to help. So. You're on mute, Johnny.
I know. I'm over here like, yeah, right.
Sorry.
Thank you so much. Yeah, love to be back. I think we're planning to be back on March 4th. We'll talk about Conforma, Salsa policies, and see some cool demos. All right.
Is it the salsa dance, Vida? It's the same thing.
Hey,
if it's not, I'm disappointed.
You're from Paris and it's evening time. Yeah.
It's evening. The problem is lately it's really cloudy, so You cannot go out. It's really something. Yeah, it's
Isan,
difficult.
are you volunteering to dance? I mean, I think you're the closest to Spain.
That's what I heard.
No, no. Actually, I'm a Moroccan. I'm a Moroccan, so I live in France actually. But my specialty is the kitchen, is the cuisine. So if you need anything, I can prepare it for you. From Italian cuisine into French cuisine into Moroccan authentic things. So I'm there.
But not dance.
No, not dance, not dance, no, not dance, not salsa, whatever. But okay, well, I'm trying.
Well, thank you to the team. I know there's still, I think, 6 people, even though you can't see everybody on the stream. Thank you, everybody, for joining. We've had a lively conversation off to the side here, helping answer questions and bring up other things. So really appreciate all of you joining. This one has been super educational for me. As I kind of alluded to before, like, I've been doing this a long time, but this industry is so big. There's so many moving parts, so many moving pieces that you can't keep up with all of it. And it's one of those, like, I am always reminded of just how little I know. If anybody's familiar with Dunning-Kruger, right? So, you start off and you think you know a lot of things, and then as you learn more things, you realize just how little you know. Like, I feel like every time I'm on a stream now, I am reminded of just how little I know about this stuff. So it really brings me a lot of confidence and a lot of optimism to know that super smart people like y'all and passionate people like y'all are involved in these things. So thank you. For our audience, as always, if you have any questions, anything that pops up into your mind, if you want to reach out and ask us, please don't hesitate to do that. Jonny, I'll ask you, do you happen to know our upcoming agenda or upcoming?
Yes. Yeah, so next week it is it's Peter Kreuzer coming back. They're going to do some more CNV UI stuff. The week after, I believe, is confidential containers. And then, so it's the 18th, then the 25th, and then on the 4th, we have the Conforma. And then, yeah, it really starts to go out after that. I can't remember exactly what it is after the 4th, but yeah, it's we've got a pretty full slate up until KubeCon EU, and then even leading into April a little bit. So yeah, it's good.
Yeah, I know we've got I've got a couple of things that I want to talk about with OpenShift 421. I opened in the chat at the very beginning. I pointed out that OpenShift 421 is available now. So anybody who wants to go and deploy it in new clusters, absolutely, it's fully GA. I believe that the fast channel is open for updates.
It is.
But so if you want to wait on the stable channel for updates, remember it typically takes 45 to 60 days for that to happen. So just please be patient on that. But fast channel updates are fully supported if you want to go ahead and do that in some of your maybe non-production clusters. I also had, while I was, go ahead.
Yeah, sorry, Sully, just if you can do a reminder to our persons who sees us that our product is always available for them with the trial versions. So so anytime they want to test anything, just go to the right place and test them.
Yeah,
awesome.
Yeah. What was I going to say? I was at Red Hat 1 2 weeks ago. Gosh, time flies when you're having fun. And one of the folks that I chatted with there was from the RHEL team who does their live streams. So Brian and company, and they reminded me that, hey, it's been a few years since we went back and did some basics with OpenShift on the live stream. So if anybody watching, if you have any requests for, like, I'm going to say OpenShift 101 type of topics, whether it's install, whether it's configuration, whether it's, those sorts of things that we haven't done. And I realized when I was chatting with Jonny about this, we're coming up on 6 years of the stream, which is just crazy. We started in May of, the OpenShift live stream started in May of 2020, and then this stream started in, I think it was August or maybe September of 2020. So it's just crazy that we're coming up on 6 years of having been here and chatting with y'all and interacting with y'all. So if anybody has any requests for anything that you want us to show, don't hesitate to reach out. We're happy to cover all of the bases. And as we talked about last year when we rebranded from Ask an OpenShift Admin to Ask an OpenShift Expert, don't limit it to just admin things. I love having Isan and Lance and company and Vita, even though he had to drop, everybody here to talk about this other side of OpenShift, which is kind of the reason why we're all here, right? Without apps, without developers, why do we have OpenShift? It's not just for us admins to watch the blinky lights and keep things running. We have to have things to run. With that, Jonny, or sorry, Isan, Lance, if you all have any last words, please do, and then I'll hand over to Jonny.
Nothing here. I really appreciate the opportunity to come share this stuff.
Yeah, I'm really happy. Really happy.
Awesome. Yep. Sully was like, I'm out. He must have had a network issue. Or no, there. Anyways, all right, yeah. So one thing on the OpenShift 421 bit is there was an update, and I think it was Cryo, where they no longer support the short names of. I just realized I did like the Trump hands right there. I'm sorry. All right, I'm sorry. They no longer support the short names. So if you have like Nginx :latest or Nginx, and then the tag or whatever, it will automatic the pod will fail to start, and it'll give an image pull error. So now you have to use the fully qualified registry name. So it'd be registry, image, and then tag. So just something to keep in mind. It's not a bug. It's a security feature where they want you to use the fully qualified name. But I don't know if I don't think it got a lot of press, and I think a lot of people were running into it when they were kicking the tires with 421 when it came out. So it's a Cryo update, and that's what's going on with it. Isan, thank you very much for coming on and doing the demo. I know it's not easy to put yourself out there and do these presentations and then do demos, and then when it doesn't go according to plan, it's hard to rebalance or refocus and get yourself back together. But you held it together. You did awesome. And
Thank you,
Rachel,
man.
like the plugin for the dashboard is awesome. It's super simple. It like simplicity is like. It's not like I'm not trying to say it's a bad thing. I think it's awesome, right? Because when you can just click on something and you've got a nice clean dashboard and it tells you all the things that you need to know, that's exactly how it should be. And you make all the hard things easy by making a simple dashboard like that. And we'll see some more of that next week with Peter's group and the CMB stuff, because of like they're doing something very similar where they're making the dashboard simple, they're making it usable, and when it's simple, it's consumable. When it's consumable, people actually use it. And that's what we want people to do. We don't want shelfware. We don't want all these awesome products that don't get used because nobody knows how. We need these things to be simple. And yeah, the dashboard, the website, I think they were great. So good job.
And just if you let me, Jonny, I wanted to say something which is really important based on my experience with the end users. The dashboard is really, really important for any enterprise who use TAS. They not just give them the idea about the product, how it's work, if it's up and running, but also they can provide and show a real business metrics that's really important for them. So how much artifact that's really signed, if there is any a security thing that happens there, it's really, really, really important. It's not enough to provide a product, to give a product, but also there are managers for that enterprise, or maybe the other persona that are not really technical, but in somehow it really involved with the product. So they need to show and see some things. So that it's really, really important from a business point of view.
No, absolutely. And like Sully and I come from a very similar background. We actually come from the same background. But like we have managers that we report to, right? There's all these data points that people need. And then we also have like security teams and all of these external teams that are like, they're trying to get information about the system for security purposes, auditing purposes, whatever, compliance issue, whatever it is, right? And so we need to be able to give them access to these things, where before it hasn't always been easy. And now having all these like read-only dashboards, or a place where they can just go and get like real-time feedback on what's going on in the environment, where I don't have to stop what I'm doing to provide that information to them, it's really important. But then back to the ease of use. If you give them a dashboard and it's got too much information and then they have to go and dig, you end up spending more time training them how to use the dashboard.
Yep.
So I think when you have a nice clean interface that people just, here's exactly what I need. And if I need to dig in, I can click on this thing and it gives me more detailed information if I need it. So well done. I think it's awesome.
As a manager, I resemble that remark. Thank you.
I know, my man. It was for you.
Awesome, thanks so much. I just wanted to add that to me, simplicity, that's actually a compliment, because I think you don't want to clutter a UI with stuff that's just to make it look pretty, or you know, or terrifying, depending on what you're trying to go for. But yeah, to just see what do you need to know immediately, the most important things. And yeah, the health of your trust root, I would say that's probably the key most important thing you'd want to know. So, but yeah, thank you so much.
Yeah, no, you did good. It's awesome. Cool. Well, hey, thank you very much for coming on. I know, again, it's not easy to do this, and you know, we understand that, and we appreciate you coming on and putting yourself out there for us. And yeah, definitely learned a lot, and looking forward to the next session and stuff like that. So yeah, awesome. Can't wait to see you guys again.
Okay. Thank you, everyone.
Thanks, y'all.
Thank you.
See ya.
Thank you for having us.